All right, hey ham students, here we are. We're going to practice lessons 6-4 and 6-5. So I hope you guys are all doing okay at home. I know this has been tough, but I pray for you daily. I want you to know that. If this is too loud, turn it down. I'm actually wearing my son's headset that he plays video games with to see if the mic works better. So if it's not working for you, turn it down. I don't want to be so annoying that my voice annoys everybody. Okay. All right, you guys, here we go. So let's start with this first one, and we're going to plot these and label the points on our polar graph. So if you look over here, this is a 30 degree, this is 45, and this is 30. And that would be half of 30. So basically it's going in increments of 15 degrees on this polar graph. So we need to plot the point 4, so radius 4, with a theta or degrees of 15. So we go out to 1, 2, 3, 4. Here's the fourth circle, and we're going to plot it. I'll plot it in red. We're going to plot our point right there, and we're going to label it. That's A. You're going to have some of these on the quiz, so make sure that you know how to do it. All right, let's go to the next one, B. B is at negative 360 degrees. For this one, I'm going to go to 60 degrees first, and then I'm going to go 3 in the opposite direction. So 60 degrees is right here. I don't want to go to here, this positive 3. I actually want to go in the opposite direction down here and count out 1, 2, 3. So that would be point B. All right, point C is at 105 degrees. 105 degrees would be to go to 90 and add 15. That makes 105. So that's going to be this right here, and then I'm out here at radius 5, so that would be my point, and that would be letter C. All right, why don't you pause the video and try to do the next 3 and see if you can get those. I'll wait for you. No, you could pause it on your own. All right, so here we go. Let's go ahead and do point D. So I'm going to go to negative pi over 2, which is here. Negative pi over 2 is negative 90. But then we're going to go to negative 4. So if I was going to be here, I really want to be up here because I take this degrees and I'm on this angle here, but I want to go 4 in the opposite direction so that it's negative 4. And that I would label D. So E is at 5 pi over 4, 6. 5 pi over 4, so that's 5 quarters of a pi, if you want to think of it like that. So here is 1 quarter of a pi, 2 quarters of a pi, 3 quarters of a pi, 4 quarters of a pi, and then here is 5 quarters of a pi, and we want to go out to 6, radius 6, and label that one E. And finally, 225. 225 is, let's see, 180 plus 30 plus 45. So that's that same angle here, but we're going to go to 5, and that would be right here, and that we would label F. All right, so that's just labeling some points, plotting them on a coordinate graph, which you will be given. Let's look at number 7 now. Give 2 equivalent polar points for point B. Okay, so point B was negative 360 degrees. All right, so we can label that, and if you want to, you can even look at where B was. B's right here. So I could, instead negative 360, I could go positive 3, 240, because that's what the degrees is if I went around in a positive direction. Also, another one that would work, 3, negative 120. That's going this way out to 3. And then another one that I could do would be to go negative 3, negative 300. I don't know if anyone came up with that one, but that would be to go negative 300 and then to go 3 in a negative direction. All right, so these are the things that you need to kind of have memorized. I know I don't like memorizing a lot of stuff either. You don't have to memorize this because if you notice, of course, this is the polar axis. This is theta equals pi over 2. If you were to have a theta here, and this side is x and that side is y, then x is our cosine theta using SOHCAHTOA, y is r sine theta, and then tangent, of course, is always y over x. And then this is just Pythagorean theorem. X squared plus y squared equals r squared. Don't put those on the triangle, that's weird. Okay, so here we go. We're going to convert the rectangular coordinates to polar coordinates and round to the nearest tenth. For these, I like to draw a picture. This is just a regular old point that you learned back when you were in like 7th grade. You go -4, +3. All right, so let's find out what they are asking us for. If we're converting this into a polar coordinate, we need r, theta. R is what circle am I on out here? What's the radius? R stands for radius. What's the radius of that circle? And it's kind of like if you think of this as a vector, which I know you guys don't like vectors that much, but you can think of it as just as the magnitude. And you know, this is the old 3, 4, 5 triangle. I'm sure you all saw that. And so we are out there at radius 5. To find theta, it's going to be tangent of theta prime, because we're actually finding, I like changing colors on this thing, it's kind of fun. We're actually finding this angle in here, which is theta prime. So if I want to find the tangent of theta prime, I'm going to do y over x, or you don't even have to memorize that. You know it's just opposite SOHCAHTOA, opposite over adjacent. And then you go to your calculator and you take the tan inverse of 3 over -4, and it will give you a value of -36.9 degrees. Now, of course, that is the angle that we're looking for is not that angle. The angle we want is that angle there. So I'm going to take -36.9. I'm just going to add 180 to it since it's already negative. Same thing as just subtracting that from 180. And so I get 143.1 degrees. You can leave them in degrees, that's fine. Any questions? Well, I can't answer them. All right, let's take a look at B. Now, if you want to try it on your own, please feel free to try these. And then you'll see if you're ready for the quiz. But this one is 3, -5. It's always good to draw a picture. Okay, this is where the point is. Let's find the radius r. That's just Pythagorean theorem, or the magnitude of the vector, if you want to think that. R is equal to the square root of 3 squared plus -5 squared. So r is going to be the square root of 34. Leave it in its radical form. And then let's go ahead and find out what theta is. Well, theta is, I'm going to find theta prime. And I get tangent of theta prime is equal to y over x, opposite over adjacent. And we get that theta prime is -59. Now, 0.0. There's no problem with keeping that because that actually is the angle that we're talking about. So I can go ahead and write -59 degrees inside of here, and that would be perfectly fine. If you don't want that, you can go around to 360, subtract off 59 from that. You can have that angle too. I could not do that over here because if I kept -36.9, that's down here. Well, guess what? You could have done that, but what would you have had to have done? Do you know? Yeah, change that to a -5, and that would have worked just fine too. Because if you went -36.9 and went -5, you would still be at the point that they want you to be at. All right, letter B. Here we go. Ooh, I've seen these numbers before, sort of. Let's go ahead and graph this one. 2 and then 2 rad 3. I'm not quite sure where that's at, but we'll just pretend it's right there. 2 rad 3. We're looking for theta. All right, first let's find r. R is the square root of 2 squared plus 2 rad 3 squared, which gives us the square root of 4 plus. Now, do you know how to square this? Square the 2, square the rad 3, and you get 12. So you get the square root of 16, which is 4. So we're out here on circle 4. So 1, 2, 3, 4. So r is 4, and what's theta? The tangent of theta is y over x. Oops, that's a 2. And without using your calculator, which I know you will anyways, but to find out where is tangent, what angle gives you rad 3? Anybody know? Pi over 3? Now, if you used your calculator, you got 60 degrees, which is perfectly fine too. Just thought I'd try to see if you remember from the unit circle. Oh, I miss you guys. All right. Are you still working on Gigi? Okay, now we're going the other way. This is a polar coordinate. We need to find the rectangular coordinate. Here we go. So this is starting as r and theta, but we need to get this to x and y. And you don't have to draw a picture of these. If you know that x is r sine theta and y is, nope. Please tell me. That's the hard thing. You guys can't tell me when I'm wrong. X is r cosine theta, which is so funny because guess what? It's written right here. R cosine theta, sorry, and y is r sine theta. All you have to do is just plug them in. Yeah, I know, it's that easy. So we would go with x would be 5 times the cosine of 45 degrees, which is 5 times rad 2 over 2. And what am I missing? Oh yeah, sorry guys, negative 5 rad 2 over 2. And this is negative 5 rad 2 over 2 also. So the point that we are looking for, and you're probably wondering, do we need to have it in exact answers? Well, when we're dealing with 45, 30, 60, pi over 6, 11 pi over 6, probably. I would think so. Okay, here's the next one. X is negative 3 cosine 11 pi over 6. So let's figure what that is. We have negative 3, and then the cosine of 11 pi over 6 would be, we're going to use the reference angle pi over 6, so that's rad 3 over 2. 11 pi over 6 is in the fourth quadrant where cosine is positive. So we get negative 3 rad 3 over 2. Y is equal to negative 3 sine of 11 pi over 6. So that would be negative 3, and the sine of 11 pi over 6 is negative 1/2 on the unit circle, and so you get 3/2. So when you write this as a point, make sure you write this as negative 3 rad 3 over 2, 3/2. All right, last one of these. Got to switch colors because that's fun. All right, guess what? I didn't read all the directions. It says use exact values, so I'm glad I was. Look at that. I must have made this worksheet. All right, here we go. X equals 2 cosine of pi. And if you know cosine of pi, of course, because if you're looking at the graph of cosine, you know that the cosine of pi is right here at negative 1. Anybody? No? Just me. Okay. So you went to the unit circle instead, and you went to pi, which is over here. And the cosine of pi, of course, is negative 1 right there. And then y is 2 times the sine of pi, which would be 0. Now some of you are yelling at me going, wow, you did that a really hard way. If you just look at this point is on circle 2, at pi, the point is right there. What is that point if I asked you to graph this on an xy plane? That's the point -2, 0. Easy way to do it that way. All right, next page. Go back here real quick. Aha! R cosine theta is x. How you guys doing? Taking a break? Take a break if you need one. Come back. Now we're going to convert the polar equations to rectangular form. So here we go. R equals 1. Now, we don't like R. R is bad. We like R squared. So what I'm going to do is I'm going to square both of these sides. And I get R squared equals 1. Now, remember, R squared is x squared plus y squared because of the Pythagorean theorem. So R squared, what I'm trying to do is I'm trying to get this polar equation to rectangular form. My polar equation is going to have R or theta in it, but I want it to have x and y in it. So I'm going to take this R squared and I'm going to replace it. X squared plus y squared equals 1. Now, do you remember from conics, that's just a circle with radius 1. I know we haven't done that for a while, but that helps too. All right, theta equals 45 degrees. If I were to draw theta equals 45 degrees, then that would be this line right here. Well, think about this in terms of x and y. That's just the diagonal. Y equals x. So now let's do r equals 5 secant theta. Now, who likes secant? Nope, I don't see any hands raised. Okay, so r equals 5. Now, instead of secant, let's change that to 1 over cosine. So this is 5 times 1 over cosine would be 5 over cosine. So let's go ahead and multiply both sides by cosine. So we get r cosine theta equals 5. Well, where have you seen r cosine theta? Well, so we'll go ahead, instead of r cosine theta is x equals 5. And what is x equals 5? That's just a vertical line. I know, this r equals 5 secant theta is a vertical line. You could graph that in your calculator if you wanted to, when you're in polar graphing. Let's go to 4. R equals 4 cosecant theta. Try this one. You got this. Instead of cosecant, we're going to put that over sine. Multiply it over to the other side. Y equals 4. What is that? You're right. That is a horizontal line through y equals 4. All right, so those were pretty basic, pretty easy graphs. Nothing fun in any of those. The next ones are quote-unquote fun. Here we go, number 5. Now, whenever we see a sine, we really want an r sine theta because that's what x is. Whenever we see a cosine, we want an r cosine theta. Also, whenever we see an r, we really want to have an r squared. So here's what we're allowed to do. We're allowed to multiply both sides by r because r is the radius of a circle, and the radius of a circle is not 0, never 0. So we're allowed to multiply by r because it's not really a variable. Well, it is, but it's not going to be 0. So let's multiply both sides by r, and then let's make some substitutions. So what is r squared? R squared is x squared plus y squared. And what is r sine theta? R sine theta is 3x. Nope, it's 3y. Why? Oh my goodness, you guys. I really need you. Wow. X equals r cosine theta. Y equals r sine theta. Man, I need the Jerry Jins of the world to tell me I'm wrong. All right. Sorry, Jerry. Oh, Jerry's not in this class. Oops. Okay. So x squared plus y squared minus 3y equals 0. And that's the answer. Okay? All right. Let's go over here to number 6. This looks super complicated, like really bad. But it's not going to be too bad. So let's go ahead and when I look at something like this, it's pretty complicated. I want to go ahead and cross multiply. So when I cross multiply, I get 2r cosine theta minus 3r sine theta. I went ahead and multiplied and I distributed, and this is equal to 6. Now let's do some replacements here. R cosine theta is x. R sine theta is y. And do you know what this is? That's just a simple line. If you were to graph this in polar graphing on your calculator, it would be a simple line. Finally, number 7. Number 7, let's go ahead and we're going to do the same thing. We're going to cross multiply. We get 2r minus r cosine theta equals 2. Okay? And then we're going to go 2r minus, now r cosine theta is x. Okay, this one gets a little bit complicated. Now watch out. We can't just multiply everything by r because that's going to give me another r here and there. So we actually have to plug in the square root of x squared plus y squared there. I know that's kind of gross. And then what they really want you to do is add the x over to the other side and simplify this so it doesn't look so gross. So that means we would need to square, and the rest is algebra. We square that, we get 4 times square the square root. Those cancel out, we square that. This we have to FOIL, x squared plus 4x plus 4. This becomes 4x squared plus 4y squared. Let's subtract everything over, equals 0, and then we get 3x squared plus 4y squared minus 4x minus 4 equals 0. It's pretty bad, huh? Okay, we're going to learn, next chapter, we're going to do conic sections, and we're going to learn that because of that and that, this is going to be an ellipse. But we're not quite there yet, so don't you worry. Okay, so now we're going to go the other way. We're going from rectangular to polar. So this one right here, this is a line, and we need to get this line into a polar form. Now note, it looks a lot like that line, so we're probably going to get something that looks like that at the end. Let's do it. Here we go. So we have x and y in these, but we want r and theta. So let's take out x, and let's put in what x equals. Now let's see if I can get this right finally today. X is r cosine theta, and y is r sine theta, and this is equal to 12. So what we want to do when we're solving these polar equations, we want to solve for r most of the time. Just like when we're solving an equation, we usually have y equals, unless it's super complicated like this, you don't want to solve for y, you want to leave it. So let's solve for r by factoring an r out. And then let's go ahead and we'll divide by this whole thing to solve for r, and that's it. So r equals 12 over 5 cosine theta plus 7 sine theta. Okay, how about x equals 11? X equals 11 is a vertical line through 11. What does that look like in polar graph? Well, x is equal to r cosine theta. And so we'll solve for r. And I want you to go one step further because this is 11 times 1 over cosine. But what is 1 over cosine? Yep, it's secant. That's the correct answer at the end. Number 3, y equals 6. Y equals 6 is r sine theta equals 6. Divide by sine. 6 over sine is 6 cosecant theta. That's the answer. Okay, let's think about this one. I mean, you can if you want to solve and do all this stuff, but what is x squared plus y squared equals 9? That's just someone's at my door. It's Greg, hold on. Say hi to Greg. Hi, Greg. What? Yeah, we're recording. Okay. So x squared, sorry. X squared equals y squared equals 9, or x squared plus y squared equals 9. This is just a circle with radius 3. And we know that in polar graph, if you go out to 3, that's just r equals 3. Okay, if you don't like that, which some of you don't, that's fine. We could say x squared plus y squared is r squared. And then you could take the plus and minus square root, but we just need just one, because if you said plus or minus 3, well, minus 3 is also the same circle, so you don't need both. It's redundant. It's redundant. All right, number 5. For these, let's go ahead and, oh, there's a little typo here. This should be a 4. Okay. Let's go ahead and FOIL this out. So we have y squared minus 4y plus 4 plus x squared equals 4. And we're going to subtract 4 over to the other side, which will give us 0. So we have y squared, and I'm going to rearrange some things here. I'm going to take the x squared and move it to the front. X squared plus y squared minus 4y equals 0. By the way, Greg had a very good point right now. Make sure you guys are washing your hands with soap. All right, r squared minus y is 4r cosine. Nope, it's not. It's 4r, y is r sine. Why do I keep doing that today? It's 4r sine theta equals 0. And then what we can do here is we need to solve for r. Now let me show you what you're allowed to do. Go ahead and add the 4r sine theta over to the other side. And then you're allowed to divide both sides by r. I know that doesn't feel good. I know that's bothering some of you, but it's okay because r is not ever 0. Next. Oh, hold on. Okay, 2 problems left. Here we go. So these are pretty big problems. We're going to, we're given this polar equation, and we have to accurately graph it. We're going to find the maximum value of r and the angle at which it occurs. So what I want you to do is get your calculator out, and you will never have to graph these by hand, but you will have to plot them on a polar graph. So we're going to go to r equals 1 minus 4 sine of theta. Let me grab my calculator real quick. Grab your calculator if you don't have it. I'm not sure where mine's at. I'm going to have to pause this. Okay, got it. So make sure you're in polar mode. Polar. Make sure you're in degree mode. It just makes it easier. We're going to accurately graph and then hit zoom 6. You should be fine. I wish there was a way to show you my, oh, okay, sorry. I really wanted to show you my graph, but I don't think I know how to do that yet. So I'm going to go ahead and accurately graph this. You don't have to be too specific, okay? So it looks like it's 1, 2, 3, 4, 5. It goes out to 5. Of course it does. 1, 2, 3, 4, 5. Plot something there. You can even hit trace with your graph and go around it. So if I hit trace and I'm using the arrow buttons left and right, then it stops me at theta equals 45. It's nice to have some nicer numbers. So at 90, I'm at negative 3. So 1, 2, 3, 90, we're at negative 3. So then after that, it looks like if you just keep clicking around this thing, there's another good point over at, looks like, I don't know, you don't have to be too specific on this thing. So it goes around, and we're not even doing the project this year, which is really devastating. Somewhere around here, and just make it look pretty good like that. Yours is probably better. All right, so what is R? The maximum R value that we went out to was 5, and it happened at 270 degrees. The domain of this graph is all real numbers, and the range, it ranged from negative 3 to 5. Now remember how to find that? we have 1 minus 4 sine theta. Okay, and so 1 minus 4 is negative 3, and 1 plus 4 is positive 5. And then what type of symmetry do you see here? I see that it is symmetric right here. So there's two ways to say that. You could say it's symmetric over theta equals pi over 2, or I'm going to allow you to say over the y-axis. Okay, let's do one more of these and then we're done. So let's accurately graph. So go to y equals on your calculator, and we have 6 sine of 4 theta. Ooh, that's going to be a lot of petals. And then I graph, and it's 8 petals. Now, how do we find out where these things go? So you want to hit trace, and at 22.5 degrees, which is pretty gross, but that's like here, you get a radius of, oh, you know what? That's why you can go to format, which is second zoom, and you can change it to polar GC. And then when you hit graph and you trace, that'll show you that you're exactly at radius 6. So 1, 2, 3, 4, 5, 6. 6 right there. And then you trace around again, and you're down there at negative 6 over here. And you don't have to be too super accurate. Like I said, it goes like this. And then there's another one that goes to here. And then there's another one over here. Look, I'm not being accurate at all. And you know what? That's just the way it is this year. You know what I'm saying, everybody? And there's just a bunch of petals. There we go. Pretty accurate. Beautiful. Okay, what am I going to expect from you on the quiz? That's tough. I don't know yet. I'm going to be grading pretty leniently, I think. But just try and draw it as nice as you can. That's actually terrible. So r equals 6, and it's happening at all of these different thetas. 22.5, 112, 202.5, and 292.5. Your calculator gives those to you when you hit trace and go around this whole thing like this. That's how it goes, like that. The domain is all real numbers. The range goes from negative 6 to positive 6, and symmetry, all of them. There's symmetry over the y-axis, x-axis, and of course over the pole, or you could say the origin. All right, thanks. This has been great. Have a great day. Good luck on the quiz. No cheating. Bye.